The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, a group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha, everyone. Happy New Year. I am geologist Philip Ong, here with Mr. Dane DuPont of HVERI, the Hawaiian Volcano Education and Resilience Institute, and joined once again by our ASL interpreters. We have Carrie and Julie with us today. Mahalo, you guys, as always. So, Dane, Kilauea is still doing similar things as it was at the end of last year. Mauna Loa is quiet. That's the short of it. How have you been?
Been good. I enjoyed the quiet holidays. We were asking for a little bit of time, maybe not get an eruption during the holidays, and we were granted that at least. So we got to take a little bit of time off. We didn't do an update last week for anybody that didn't try and tune in or was wondering where we were. Just took a little bit of time off for the holidays. So now, we're getting back into it and got a lot of content coming up in this month.
That's right. The USGS has Volcano Awareness Month coming up. So we'll have extra talks that will be live streaming or posting after the fact if we can't live stream coming up this month. And so we will probably adjust our live schedule accordingly. We will be with you guys next week, Thursday, but the week after that, perhaps we'll break again, right, depending on what's happening with the volcano and all the other contents coming across our channel as well. Anything before we get going, Dane?
No, but just remind people, if you have any questions, go ahead and post them in the chat, and we will try and get to those at the end of the program and try and get as many as we can answered. And I'll be also in the chat, answer some of them as well.
Mahalo, thanks for leading that discussion and collecting those questions. That's always a lively place to be, as always. If you haven't caught us live, hop on there on YouTube or Facebook and join in the chat as it goes along. All right, so let's start with our Hawaiian volcano summary, as we usually do. So for Hawaiian volcano summary this week, Kilauea has continued to earthquake in its southwest rift, seismic southwest rift here, and its upper east rift connector, much as it did the previous month. And this came during a pulse over 2 days just prior to New Year's Eve, where seismicity increased first in the summit area and then migrated its way towards the southwest. At the same time, we saw a decrease in the ground tilt at the summit, while tilt increased here in the southwest. So it seemed pretty clearly a pulse of magma had come through the summit region and it was moving down the southwest rift area. And continuing the intrusion that we suspect has traversed as far as this furthest Kauai seismic southwest rift fault zone, but also includes this triangle of the Kauai zone to the upper east rift zone here as well. So that seems to be the area being affected. It's not continually flaring up, but we are having these pulses come through, the most recent of which was just before New Year's Eve. Looking at the time, it's the last week of time here versus the depth of earthquakes. All of those are in the shallow band of these oranges. So you see within the last week here was that increase in the shallow seismicity of Kilauea, whereas everything else was fairly normal. We do have continuing deeper earthquakes underneath the summit reservoir areas of the volcano, still happening at low levels and very small magnitudes as well. But it seems like the whole magma transport system of the volcano has been active, continues to be active, and it's just finding space to adjust and to fill and accommodate all that magma underground without having to erupt since September. Looking at the earthquake rates and depths for the past month, this is that pulse we just had right before New Year's Eve here. And we had a couple of previous ones you can see earlier in the month. And so our peak earthquake counts in one day were over 250 on the 30th. And it was not quite matching close to 300 we had back on December 7th. So certainly a notable event. At this scale per day, it looks like it's a little bit smaller. The USGS reports the earthquakes per hour during this event were actually a little bit higher, and thus led to a little bit more alarm and caution. Looking at the ground tilt signals at the Sandhill Station, this is just southwest of Kilauea Summit. We see that the summit component seems to be still inflating over this last few weeks. And while we do have inflation-deflation cycles superimposed upon this, you can see that the overall trend is one of inflation, maybe deflation here and inflation again. And this being the transfer of magma from the summit area to the rift zone. And correspondingly, this green component is the one of that southwest rift, upper southwest rift connector. And here you see that rapid inflation that corresponded with the earthquakes. And since then, continuing inflation, but at a slower level here. And so at present, the magma continues to come into the volcano and fill both the shallow system of the summit caldera area and the southwest rift area, both. And waiting until the next pulse, something like this occurs. And whether that leads to another eruption or more activity, we'll have to wait and see. The signals are much like last month. Here is the outlet station GPS, where it's still rising here. Not incredibly fast. I had actually paused a little bit the last couple weeks of the year, but has come up at similar rates to where it was before. Here might be at its highest rate that we've seen recently. So approaching that, but a little bit slower by this looks of the graph here. Overall, the patterns continue from a few weeks ago, where the outlet is still moving to the west. So it's wiggling in there between the Kauai and the southwest rift and moving to the south as well. Whereas at the Haleʻiʻapali GPS station, which is further afield, further from the summit area, it also has showed slowdowns, but is still showing signs of moving to the east and to the south here, suggesting magma is still filling that crack system further away from the summit of the volcano. So all pretty similar to last month, to be honest, but just catching us up since we've been paused for the holidays here, along with the volcano too. So this is a map for Mauna Loa for earthquakes for the past month. We did have some earthquakes about a month ago come in at this deep area underneath the summit, just southwest of the summit. But really, it's been fairly quiet since then. I can look at the time depth plot for Mauna Loa. Here's depth, here's time. Here's the background shallow activity. The volcano is still filling with magma. Fairly reasonable rate there, where it's not causing a lot of earthquakes. It's just filling and moving the ground back outwards, following the eruption that happened a little bit over a year ago. When eruptions occur, the ground sags afterwards in response. So now it's refilling and recovering that buildup. And that's the summary for this week. Pretty similar to last month. That's how we begin 2024. So with that said, we can look at some Kilauea observations. There isn't a whole lot of change in the surface of the volcano. That's very obvious here. Here's our KW camera showing that discoloration around that central cap of the volcano, where it still produces quite a bit of fume, as well as these outer edges as well. And I'll scroll through some of the other ones. We have an F1 camera, more on that in a minute. But the views are similar across many of the cameras here on the USGS website. Southwest Rift. Further from the east, looking at the recent eruption site from September 2022. It's looking pretty quiet there. A little bit of fume coming up right in here, perhaps. And otherwise, you still see the very edges are the areas showing discoloration and fuming coming up there and over here as well, as we'll see here shortly too. So let's turn to the F1 camera, where we do have now the camera has been restored and it's been widened with its view here, so we can actually see the full cap of the lava lake. And here's a time lapse for the last month or so since the camera's been up, or the last couple of weeks here since the camera's been up, showing how these zones of heat are really not moving at all. You can see how they stay fairly constant. And you see the flashing really has to do with the sun rising and lighting up the foreground and surroundings daytime and nighttime. So pretty passive happenings here. You can see that these other areas are still fairly hot. That's why the gas is coming out there. And you see that discoloration as minerals deposit on those vents, around those vents. So that's the on-the-ground view. We do have another contribution from Cosme on Twitter or X, Cosme64833127 here, compiling images from Copernicus Sentinel-2 to help us see here the cooling pattern of the volcano. So you saw the flash of the eruption in September, and you see the different signals here enhanced, cooling down with fewer spots of brightness as time comes on here. So those are observations, visual observations here in Kilauea today. And with that, we'll just touch base here with our volcanic hazard summary, which at these points is usually the gas. We can look at the National Park website, and when we see a circle like this, that means that winds are fairly weak. So only showing 6 miles an hour, and which means that the VOG can affect close by areas. However, as you can see, everything's in the green right here. So all good. We have good air quality right now, and the areas most likely to be affected are still nearby in Volcano Village, southwest of Pahala, Naʻalehu, Ocean View, those areas. Even at these smaller volcanic backgrounds, this is still quite a lot of gas coming out. It can affect people quite a bit if they're sensitive, especially. Still looking like it's in the green everywhere for visitors in the national park, and that's what we have to go on today here. So we'll move on to our recent earthquakes and look first at this wider USGS map. And I have here selected just the last one day, just to show that in the last day the earthquakes have slowed down here. They're fairly slow in a short term, Not a whole lot in Upper East Rift. Nothing in this Southwest Rift area right through here either. But if I pull it back to the last 7 days, now you'll see all this earthquakes populate here. We do have background activity elsewhere across the north part of the island. Pahala is still ongoing here in the south. But really, we want to focus on what's happening in Kilauea here, being the most dynamic part of the island today. Still, because of these are not colored by time, it's harder to distinguish them by population. So as usual, I'll turn to the USGS website where we can color these by depth instead here. So this website seems to always give me some issues, so I'll click my way through here to clean it up for you guys. Let's take off all the instruments so we can see the earthquakes. Let's look, we'll see earthquakes for the last 2 days here. Also showing fairly few events in this area right through here. But we'll pull it back to the last 2 weeks, or the last 4 weeks. You can see the full pattern, with the blues being the deeper earthquakes here in Pahala. This cluster thought to correspond perhaps to a Mauna Loa feeder. This area here thought to correspond perhaps to a Kilauea feeder. And we've had some earthquakes here a couple weeks ago in that deep zone along that trace towards Kilauea as well. And it's thought that this last cluster down in here might be a feeder towards Kamaehua Kanaloa, formerly known as Loihi, which did have a shallow earthquake here recently, 2.3. But one by itself is just natural for the volcano to be adjusting and moving all the time. So it's really these swarms that we're looking for to show magma movement and changing stress, continuous stress on the rocks underground there. So zooming into that, you can see a little more clearly here. And there is the Upper East Rift patch. Here is a Upper Southwest Rift patch. This is a little bit different than we saw before because prior we had seen more of a focusing right through here, but it's pretty clear that we have this bend towards the Kauai in place right here. So it's a little bit of a dog leg happening here. And this is a series of faults that connects the East Rift connector over, right? So that's interesting there as well. And we are getting some earthquakes now as well in between this Pu'uko region here to the south, which has been flaring up for a while as well. So it does seem the magma is moving its way to put pressure, it seems like, all the way down to here. And this is a place that historically has always caught earthquakes, and activity does get pinched here, we'll call it. So that's one of the question marks, is how long can this hold up compared to the other possible fail points of the volcano? And to look at the earthquakes a little bit in more depth, I thought we would do some cross sections. So I've highlighted first for the full depth of earthquakes all the way down to Pahala, all the way across. B's in the top right, A's in the bottom left here. And if I show you what this looks like, these are earthquakes for the past month. There you see the Pahala cluster. This is the Mauna Loa patch there. This is a Kilauea patch. Here's a patch closer in line with the trend to Kilauea. Something like that, perhaps. Try a question mark on there. Here are the deep earthquakes we saw under Kilauea about mid-December that began. So that would be part of that pathway coming upwards. And here is that summit area with that East Rift connector. This would be the Southwest Rift area. And this would be that Pu'uko furthest over area to the southwest. And so you can see that this is starting to overlap a little bit, where you have some interaction of this pressure and events happening both between, and we're also getting adjustments in between those here as well. But these are intermediate earthquakes between the deep Pahala zone and the Southwest Rift. So that's one view of it. If you look at the rates for the last month, these are the earthquake counts over the last month. So when this line is steep, they're happening very fast in a short amount of time, a little less fast, faster, still pretty fast, just not as fast. And when it does these little stops, that's when it's slowing down. So we had a little slowdown here just before the end of the year. And here recently, that was that recent burst. And now it's continuing, but at a slower rate, has not really stopped yet. again. This is, once again, depth versus time, but for that area that I selected. So Pahala earthquakes are fairly constant. We can look past those to see these being the deep Kilauea summit earthquakes right there. These ones are the ones in Pahala over here, the yellow ones. So these are the pulses above of magma coming into the system where it really flares off in a shallow system. So three clear clusters visible at this 1 month time scale right here. But we can learn more if we zoom into just this little surface area, just the shallow earthquakes over the last month. And if we do that, A once again is in the bottom left and B is on the right. Here we see the full range of depths of these earthquakes from left to right. So furthest to the southwest, you can see the earthquakes that have gotten the shallowest over here. And actually, these maroon colored ones are all above sea level here, right? So you can see that the further you go to the west, the shallower they become towards Pu'uko. That's interesting. And this is that area, Pu'uko, you see active across a big range of depth. That's typical, as these are long cracks that are usually have a very, very big vertical component. So they're very tall and skinny. And you'd expect it to activate across a range of depths here. So that's further to the southwest, coming closer to the summit. On the other side, this is the East Rift connector. You can see it's active all the way up and down, but at a limited depth here as well. And there is that full range near the summit that connects these systems together here. Now, looking at this, at the rates in a shallow region. Just a second. So looking at the earthquake rates in a shallow region, once again, a steep line is fast and slower, faster and slower. By doing it in the shallow region, we're filtering out that deep earthquake signal of Pahala as well. So it's a cleaner signal here. You can see in the shallow regions, it does seem a little bit slower here in recent times, recent days. So the seismicity is more recently, within the last 2 weeks, playing off the deeper and shallow regions together, contributing, which is interesting, right? I've heard some presenters at AGU discuss this, how it could almost be sucking up magma, right? You have all the magma flowing out through the shallow system, and it can create a pressure differential in a way, and almost try to suck up magma from below through that system. That's one possibility, as opposed to, let's say, it's surging from below and it's pushing everything above it as it moves and propagates upwards. So that does not seem to be quite what we're seeing here, but we may be seeing some of the sucking effect a little bit coming up. So this final one here is also depth versus time of this shallow segment. Right? So here's our 3 clear pulses within the last month, 1, 2, and 3. And what's interesting is that if you look at the top of this largest cluster of earthquakes, they seem to be getting progressively a little bit shallower with each pulse here. Right? And not only that, the ones that are in the shallowest above sea level region also seem to be getting shallower and shallower as time comes on as well. So these ones we described being down at the Pu'uko, the furthest southwest part of the system there, which is just going to show that if the magma pulse is working its way from the summit all the way southwest and filling that crack and putting pressure, it seems to be reaching shallower and shallower levels of the volcano and getting closer to the surface there. And this is interesting because that really is a possibility that if a downhill part of the rift system fails, it could then cause draining of the system from the summit towards that area. Like we discussed recently at the end in December, that could be similar to 2018, where it happened on a southwest rift, right? So to be clear, this is all happening under the national park, away from people. There's no increased threat to people. But it is interesting to note this pattern here, the southwest rift, that would potentially lead to activity within a national park. Dan, you want to add something to the earthquakes here?
Not really. I mean, it's just been interesting because it was great, the timing of the USGS. They've been putting out stuff on this seismology. We'll talk about that a little bit later, but to see the little bit more and more info come out, and I'm hoping that when the Bahala talks happen and the After Dark and the parks and the Volcano Awareness Month, everything happening in the next month, we start to find out a little bit more about the gray areas that we've kind of questioned for a while, like Bahala, right? How does that tie in, and details along that would be great to know. So yeah, and it's always hard for me when we have quakes that are easily identifiable, but then you have when they start meshing over each other, right? The one that comes to mind immediately was the 5.0 that preceded the Mauna Loa eruption, maybe 6 months out from it, prior to it. And that one, it immediately looked to me like, oh, this is just a big Pahala quake. And then they adjusted the depth a little while. Then they're like, actually, Mauna Loa. It's like, all right, so it's just, it's, I don't have the background you do in the seismology. And so those start to get gray for me, right? And hard to call on what exactly kind of quake it is and what does it mean when it happens.
Right. Yeah, so we'll see what they cover here in the upcoming talks. It'd be great to hear some of that. I'm sure they'll cover the basics as well, because they're always trying to make sure everyone's caught up to the same page here. So
yeah,
we will be excited to bring that to you guys. So that's the earthquake, the pure earthquake section that does blend into our monitoring as well. So we'll talk about Kilauea monitoring. And we'll start with the USGS information statement on summit unrest that they released on December 30th, as this activity was commencing here. So they did note at the time, elevated unrest and increased seismicity to the south of the summit started December 29th at 1 p.m., followed a sharp increase in inflation on a sandhill tiltmeter. They described some parameters here, but essentially they are saying that the activity has begun and there's significant intrusion ongoing to the southwest of the summit there. They do note at the time, earthquake swarms like this can precede eruptions, but there is no lateral or upward migration of earthquakes that would suggest magma is moving toward the surface at this time. So that was their short-term prognosis there. Okay, certainly we're watching closely, and we can get more of a hint of that if we look at their updates, their daily updates here, starting on the 30th. So I'll just highlight a few sections of this. Let's see here. By the 30th, they said there were 350 earthquakes, most less at magnitude 2.5, at depths of 0.5 mile to 2 miles down. The increased seismicity began just south of Halemaumau, and that area has progressively widened to the southwest toward the Kauai fault zone. The current rate of earthquakes is slightly higher than what was seen in October during the unrest that accompanied the magma intrusion in this area. So that was the key thing there. The rate of earthquakes was slightly higher than they saw in October. The rest is, similar details here. That's all the variations are expected to be short with it here. And let's see. Yeah, we'll move here to the next day, to the 31st. So on the 31st, they note that there was the end of the seismic swarm, coincident with a drop in inflation recorded at Sand Hill. Let's see, coming further down. Locatable earthquakes averaged about 15 per hour during the height of the swarm, with a peak of 27 per hour. By noon on the 30th, the average number of earthquakes dropped to less than 5 per hour. So it's a little hint that even though we're looking at these earthquakes and rates per day, really you need to be looking at them at rates per hour to keep track and keep pace with the USGS and how quickly, what scale they're watching this at. So they do note earthquakes south of the caldera increase at a lower rate, and the seismicity has progressively widened to the southwest. So that's all fairly similar. And then they do add a section here a little further down. The strong swarm of earthquakes and rapid inflation that occurred south of the caldera on those days indicated magma was being placed at relatively shallow levels. And so here is the new text that they're adding. This particular event led to an intrusion, but it is possible that similar events might lead to an eruption in the future. Currently, there are no signs of imminent eruption. So that is the highlights of the updates here, the most important stuff that's in there. Looking at today's update, we can catch up. And you can say that over the past day, seismicity has been low across all areas. Unrest is expected to wax and wane with fluctuating input of magma to the area. And eruptive activity could occur with little or no warning. No activity is unusually observed there. So we can come down and we can see that the same text is repeated once again in the days since then about how that particular event led to an intrusion, but it's possible others could lead to an eruption. And that is basically it. They have been noting separately seismicity in the rift zones, the Upper East Rift Connector and the Southwest Rift as well. But we've been looking at these all as a population together. So we'll just leave it at that here for our purposes today. Turning now to Kilauea's data for the last week. Earthquake counts were high just before New Year's there. We looked at this graph, and I did want to zoom in here to just highlight this little patch of deeper earthquakes under Kilauea summit that has followed the shallow seismicity. So shallow seismicity all through here. And if you were not with us a couple weeks ago when we described these deep earthquakes, this 10-kilometer line seems to be a dividing line, more or less. This plot captures all the earthquakes, including the South Flank earthquakes. But South Flank earthquakes generally are right above that line, whereas the earthquakes just below that are the ones deeper in the summit. It just happens to be the case right now. So for now, we can use that as a little guide, a little proxy, and know that these are the deep caldera earthquakes happening here. And these ones, these yellow ones here, that would be the flank, for example, right? So lots of stuff still active on the volcano here. Over the last week, we see deflation and inflation dominating the signals. And really, the overall pattern is still one of inflation. The GPS up signal for the South Caldera station is showing that normal scatter because we're so zoomed in here. Our scale is really, really magnified. So we're seeing the noise in the data. But maybe you could say, okay, the midpoint there, average of these midpoints is generally going up here, right? Which is not surprising seeing the other GPS data we see. The E signal by and large is a little messier, but the point being that we expect when something is majorly happening, all this scale gets recalibrated. All of this other data gets squished together, and you'll see some new point somewhere off to the right that's really quite a lot different from what we're seeing here. And that's what we're hoping to see in these instruments. So there's the earthquakes for the last week, showing the South Flank still active there. There's our Upper East Rift Connector earthquakes. And as I pointed out, these different patterns further to the south here. Moving on to the last month point of view. And we looked at the 3 humps. Here's the 3 pulses over the last month. In depth versus time, you can see those there, there, and there. Deeper activity there. And if we look at our 10-kilometer line right there to distinguish our deep earthquakes, here's the beginning of that deeper stuff here where it really picked up with these green ones through here as well. And that was the height of it. And since then, slowed down. It seemed like there was a little gap here just before that most recent seismic swarm. and then they picked up again. You see the green ones coming back in here as well. And this is that little patch I highlighted for the last week right in here. So that's how it all fits together. I'm trying to expand the time scale from the week to the last month, and we'll come to the next year next. But still, for the last month, there's a pattern for the summit, clearly increasing tilt. Maybe you could divide it into 2 stages if you wanted to, like that. And clearly the deflation-inflation cycle, superimposing it, make it really impossible from any one particular day to know what's happening on an overall trend. So if you look at one day and you say, oh, it's deflating, you might just be in a deflation-inflation cycle, which ultimately is irrelevant to this overall larger pattern of it coming upwards. So that's really what matters. It's coming upwards. It's swelling at the summit. That's the green, the blue line here, similar to this one. And the green line, as we described, the southwest rift is also inflating. So this is an interesting thing here to think about, is if the supply is really kind of low and it's just filling into the summit area, then you'd expect it to maybe be filling the summit and not enough of it pressurizing to go in the southwest rift, right? The southwest rift could be deflating while the summit is inflating. If you get to some kind of moderate rate of magma coming in, right? And we know the magma comes in pulses. So let's say a pulse is coming up and it's like a moderate rate. Then you might expect to see it pulsing through, filling the summit, and then moving through the summit into the southwest rift, with the summit then deflating as the southwest rift inflates, right? You almost can see the slug move its way through all the way, because it's enough to fill the summit, burst into the southwest rift, and then to then deflate afterwards. The third possibility there would be if you have a very strong supply. And if that's the case, then you see it filling all the summit region and bursting into the southwest rift and filling it at the same time, and everything activating, swelling, and rising all at the same time. So it seems like that's the kind of range of what we've seen here. Sometimes it slows down, sometimes it speeds up. Sometimes we see both summit and the southwest rift inflating at a fast rate. Right now we see them both inflating at a slow rate with not as many earthquakes. So it seems like there is something more passive happening there. But interesting to note that that system fundamentally remains open, it appears, right? So that's really the takeaway message here. It's a very large network that's been activated here, with magma can work its way all the way down to the southwest rift area, all the way to Pu'uko, and possibly be moving towards the surface, closer to the surface, not to suggest it's moving to erupt there. Then that does open some possibilities, as we'll see here in a few minutes. But continuing our monitoring summary, on the east rift zone, the signal has been deflation. There might be some rain signal here at the end. And if not, there are natural variations as well, but still fairly small scale. Further down on the rift zone at Jonica, you see deflation as well. In fact, it's a little curious. The deflation seems to have accelerated since Christmas Eve. Still deflating, but it's deflating even faster now. So I don't know if that's some other effect as well going on there as well. South flank motion perhaps. But there you go. Our summit SO2 is still low. The scale is what matters here. This value is pretty close to 80 tons per day, which is the background at the volcano, but still would be polluting at industrial levels if it was a factory nearby. So if you'd be concerned living next to a factory, then you can be concerned about living next to the emission source of Kilauea, even though it's natural. And not as high as it gets during the beginnings of eruptions, but still affecting nearby areas, as we pointed out earlier. So here's the last month of activity, the map for all those earthquakes. And you really can see here that full pattern we've been describing, this magic triangle of Kilauea up here, where it seems to be filling perhaps more passively with less earthquakes in here, and with more earthquakes perhaps because of this larger filling area, movement to the southeast here, and that combination of magma and fault zones and the pressure that it puts on them. All of that being the components to what we're seeing here today. Okay, with the last year perspective, our SO2 is really quite low compared to how high it's been. It's been up at 200,000 tons per day. So really 80 is pretty low. even if it would be polluting at industrial levels. Our earthquake counts, now we're displaying them in earthquakes per week over here. So they are still high at 800 per week last week. You can see this natural variation coming up and down, and an extended period since the beginning of October of this pulsing seismicity. And this is really in contrast what we saw in the build up to September, where it erupted and then dropped down. And in June, it built up to eruption and dropped down. And back in January, where it dropped down for the eruption, we don't see the buildup because it was over a year ago now. But that's what's been the difference here. And what we pointed out early on seemed to be a different pattern of the volcano that could be manifest in different expressions, as we're seeing now, this extended intrusion into its fourth month, perhaps, right? If you could count it all as one big episode with various pulses. And during that same time, here is our beginning of earthquake swarms. If we come down to our summit GPS line from north to south across Kilauea caldera, that corresponds right here. We had a big change in the average spreading rate north and south across the caldera at that point in time. It's still spreading, but it's more slow. And that's because a lot of it's actually feeding into the southwest rift, and it's not all feeding into the summit. So that's the key change right there. You see this wiggling up and down. It's building up the summit. It's relieving in the southwest rift, building up the summit, relieving, build up, relieve, build up. And so that's what you see going on with the pulsing at the summit signal, while still at the background extending and getting wider than it was before. And in case you're curious, over a 1 year time frame, we have, let's see, this is showing minus 0.3, and this is up at positive 0.35 almost, right? So you're looking at 65 centimeters of spreading in 1 year, right? In case you're curious, that's on a range of 2 feet. So that's how much further one side of the crater is today from 1 year ago, just from the spreading and filling with magma, movement of the south flank, the Kīlauea being shoved to the side as magma comes in. So this is a very dynamic system. In other places of the world, geologists are measuring rates in millimeters per year, right? And so here we are at 0.65 meters per year. It's really a massive rate of change. On the rift zone at Pu'o'o, we're seeing a contraction. You see the scale is much different here, a lot more zeros in the front, right? But still, distance is getting closer together. It's going down as the whole thing sags and contracts, as magma does not appear to be feeding into the rift zone anymore. And in fact, seems to be going, whatever was in there, seems to be perhaps sinking down into that deeper rift area towards the Tacoma and that south flank base that slides and moves apart. So that allows the top to then deflate and sag and contract while still moving to the south. And that's our GPS signals there. We could also look here, just since we are at the start of the year, at this other time frame, depth versus time, and you see how many earthquakes we have for the last year in this Kilauea window. 27,000 in total. Hard to distinguish through here the different pulses. For the last 5 years, it's just as crazy. 108,000 earthquakes for the last 5 years. And earthquake counts overall, you see, have been increasing over time. But you still see this spiky nature, uneven up and down and up and down and up. And so that's earthquakes per month, showing this how it's uneven now with this south caldera activity. And the summit GPS shows it fairly clearly too, this change in slope that we saw in October here, with these little bumps being the 3 eruptions we had last year in September and in June and a year ago in January right there. Right? And going further back in time, September 21 and December of 2020 back in there. And the rift zone is important to look at, right? So the rift zone was showing magma coming into it, in this region, this era post 2018, up until mid 2020 or so, somewhere right in there. It stops really extending. And it seems like magma was likely feeding into both the summit region and the East Rift at that point in time. And once it erupted at the summit in December 2020, then you see that East Rift filling cease. And in fact, that's when it starts contracting, and it's essentially contracted most of what it gained in that period of time. It's almost back down to where it was post 2018. And so with that, I thought we could look at the, let's see, what do I have here? Okay, so this is the from back in October, earthquakes per day. And just to show that the peak when we began was 350 earthquakes, 300 earthquakes per day. And so since then, we've had other pulses, 150, 250. 250 seems to be somewhere we reach fairly frequently. Here we have November, where 250 once again, there's 200. Right, and then for comparison, what we saw here on Kilauea, let me find the right plot for this past month here, where once again we're right around 250 once again. And so it was actually pretty typical what we saw just before New Year's Eve, of this increase in activity of similar counts. Okay, so now let's go to the GPS, the 2-year GPS. And just to highlight here, our stations around the summit are doing much of what they were doing before. Ukahuna is still moving to the west and north, and it's still rising. The important thing typically is the up and down signal, this component right here. So it's still rising at a decent rate, showing the summit still filling. Over to the east at Byron's Ledge, also still rising, and still moving to the northeast. In the south, we see Crater Rim. Crater Rim is the one that was wiggling a little bit, right? So it's still moving east. It was moving to the south. It got pushed back to the north as that intrusion pulse went down the southwest rift. Seems to stabilize, and maybe now it's maybe moving back down to the south again, right? Showing once again increase of pressure at the summit, Halemaumau area, while also still rising. In the southwest area, the outlet, that junction point into the southwest rift, still rising. There was that little gap right there, but rising and moving to the south. And this is an interesting one where it's caught between a Kauai and a southwest rift, where now it's getting pushed to the west, actually, which in my opinion would suggest you have a fairly strong component of the Kauai, right? Magma is moving into that triangle zone south just as much as it is to the southwest in order to be pushing this station to the west here. So that is the key of it. If we look just scanning on our south flank stations, Ahua is still rising, Puhimau is still rising, Devil's Throat still rising, and all these stations are still moving east and south, pretty consistently across the board there. Where it gets interesting is Makaupuhi and Kalapana Trail. These are stations that are on the south flank, just south of the rift zone, and Kalapana Trail in particular. So these stations are all dropping. This is near that pinch zone, the entry of the East Rift Zone. And this station has been moving north. This is a 2-year plot. So for most of the last 2 years, it's been moving north. And in that case, it actually is pinch and close that rift zone in that area. So we'll come back to Kalapana Trail in another minute. But to finish off, for the last 2-year plots here, we can see that to the southwest, Ilemakuli all the way at the coast is still getting pushed east and south, not really rising too much. But Hilanapali also is moving, maybe hard to see, but it did slow down. Now seems to be rising again, and still seems to be rising in the middle of all the scatter here to the east. To the right, I should say here. Okay, so everything else is as expected further away from the eruption site. On the East Rift, all the signals basically are down and to the south and to the east. Southeast and down, southeast and down, and down and down everywhere, right? Because all of the East Rift Zone is southeast of the summit, and the summit's really what's pushing the whole Southeast Rift as a whole unit over. So that's why they're all showing the same signal and everything is syncing That's the key there. But to look at the GPS in a slightly different timescale, let's go back to the last 10 years, as we may be feeling a little more retrospective today here, and compare this big signal right in the middle is 2018. So you see here's Uekahuna's up signal, and it was getting pushed upwards, upwards, upwards. Here's a big collapse, and here's how much it's recovered since then. Right? So here we are still marching right back. We still have not recovered the full drop in land up on the crater rim of the volcano, right? Not talking about the pit, but the actual rim up further up where people stand and look down into it. That whole area sagged down quite a bit also and has been steadily rising up too. All those patterns are similar across all these summit stations. But most unique, what you notice here is up signal is fairly consistent in the north. When you get further south, that's when you notice this outlet signal right there. There is that intrusion signal we've been seeing since October, and that's what it looks like in context right there. And note how much this station dropped in 2018. This is also outside the caldera, right? Outside the crater on the rim on the south side, but still showing how much that dropped and how it's, even with this intrusion now, has only recovered a fraction of that. It can still fit a lot more lava in there to get back to the point where it was in 2018. If you're curious what other events are notable in this plot, here is that August 2022 intrusion as well. You go back to 2015, that intrusion shows up too, way over here. That's how they usually look. They're usually smaller. So in that context, this one is extended and much larger. It's just in comparison to how much room this thing sagged, right? If you think of it as an accordion, and the accordion is getting stretched out, right, with this collapse because one end of it's getting pulled down, and now it's getting refilled and pushed back together. It's got quite a lot of give still, if you look at these data plots in this context like that, right? This is the up signal. If you look at north is a little trickier because this whole south flank is always pulling the thing to the east and to the south, even before 2018 collapse, right? So there's a little bit more complication there. But that's one cool thing to note there, and one station to point out. Otherwise, there's a signal that we noted at the East Rift zone of how the East Rift was filling to 2022, and then now is not. It's dropping down and moving to the south and to the east. That's Kananuyohamo, Kamamoa, similar signals, Pu'o'o, all the rift has that same pattern right there. When we get to the south flank, these ones are the ones in the Kauai, really. I probably could break these out into a separate category now that we have action there localized. But Kauai is Puhimau and Ahua, showing that little rise right there. And Devil's Throat is just barely registering in comparison to this other two. So activity definitely is focused towards the west of the Kauai, as we know from the seismicity being there too. But the interesting thing comes here to Kalapana Trail. So this is the one I wanted to come to and end on, because it's this north-south signal that's really curious to me, where you see for years and years and years, Kalapana Trail is moving to the south as magma is flowing through the rift zone to Pu'o'o, erupting out of Pu'o'o. And we have that 2018 event, disruption there. It then is moving to the south even more, even faster, as magma is filling the East Rift during that time up to 2022. Right, before mid-2022, this is actually late 2021, September 2021, that's when you see this thing change, and it starts moving to the north and sagging down at the same time. And so there is your key of when the East Rift Zone blockage began, or was effective. And what we're looking for as far as what might happen with the East Rift is, when does this thing turn around again and go down? Because that would then open the East Rift and allow magma to resume its preferred path to the area of Mauna Ulu or Pu'o'o, where it's erupted for years and years and years and years in a row, right? And restating once again that the lower East Rift area further off than that, towards Leilani and beyond, is much rarer, much less frequently activated. And that's really was the worst case that we saw in 2018, where everything was lined up in just the wrong way to propagate all the way down. So now we have to work the upper sections quite a bit before we can actually move activity towards the lower part of the rift zone. And so we're tracking that progress. Perhaps 2024 will be the year where we actually see the East Rift Zone start to fill again. And then eventually that would lead to more eruptions in the Upper East Rift Connector, likely all in the park. And then as expected, further on in a range of decades, you eventually can move back into the Lower East Rift and use it as well. Very generalized, of course, right? You never know what the volcano does exactly. But that's what we would expect based on patterns we've seen in USGS statements following the 2018 eruption, and all the data we've seen ever since then. All of it seems to all be matching up. So nothing standing out as obviously wrong or out of place there. All of it's making sense. And with this, really, this is the key thing. Kalapana moving north. I wanted to then just come to Google Earth here and answer one of the questions that we always get is what possibly could happen with what's going on now. And I thought what I would do today is just put on the map all the flows we've discussed over the last 3 months of all the possibilities of what might happen. And so I've put in flows, excluding ones from Mauna Ulu and Pu'o'o, because Kalapana Trail station is this one right here. Whoop, come back, please. Hold on. Right, that one right there. Right there, right? So this is the area that's moving to the north. And if this thing's moving to the north, that's where it pinches this rift zone close. So let's presume that this is pinched off and what could happen in the situations. Well, in the mid-Mauna Ulu era, when there were blockages at Mauna Ulu's eruption, there were eruptions that happened in the Upper East Rift in line with the Kauaʻe. So for example, moving from east to west, there is 73. November to December, there's a crack that became a fissure that's right in line with the Kauaʻe trend, as you can see right there, right? The purple one was in 79, very similar, 3 different cracks in that same trend. The orange one was 73. This is actually Hiaka crater and Pauahi crater. So same trend. So an eruption anywhere in the Upper East Rift Connector, especially with fissures that are in trend with a Kauaʻe, are a possibility. Right? This seems to happen more towards the south than in the middle here, just based on, you can see, lack of pit craters, lack of many eruptions through here, right? That kind of thing. You can get it up here as well at Puhimau. There does seem to be something that activates right through there as well too. So that's one possibility. Another would be that it doesn't actually make it into either rift, but it pops out near the connector, near the surface at Hale Ma'uma'u. So here are eruptions from previous era that would fit that bill. We, of course, just have been seeing this at Kilauea Summit for the last year. Our September 2023 eruption is not unlike this one, which was actually April and May of 82. There in that downdrop block area. This is not a surprise if you remember the imagery of 2023 September when we saw the 82 fissure sticking up through lava flow as one of the most recognizable features there. Very similar area. Going further back in time, this is 74, or resembles some of our our earlier 2021 activity. Pardon me, I'm not sure if you can see me. Maybe I'm frozen.
Yeah, I think you froze there, Phil. And go ahead and take a drink of water. It's an interesting map there. You know, with so many different lava flows that overlap in those regions. So when you get to have the individual layers and then start going through them step by step, it's really interesting.
Yeah, so if you can still hear me.
Yeah, we can hear you.
I'll wait till this comes back on to move it around here. Otherwise, I might pop off for a minute, Dane, depending how this plays out here. So yeah, on a map, so that big pink area. Oh, am I still here?
Yeah.
All right, my screen went blank. So it's pink, big pink area. That's the which one is that? That's the 74 eruption. July 74 right here.
Oh, you're back. There we go.
All right.
Hey.
Right. So yeah, similar to these Kauaʻe trends, and you know the caldera, South Caldera fault structure is more or less like this, right? And cracks in this direction. And that does mirror the Kilauea down here, right? That's not coincidence. But you can have cracks also closer to the summit, right? Where you can have it popping out. And 74 occurred along the rim right through here, but also a little bit further to the south at Luamano, this pit crater right here, where you had fissures somewhere in there. I'm sorry, I'm off. Like this is Kanakakoi. So here's Luamano. So you had fissures that occurred. I think there was one like right there, and there are some in here as well, maybe through there, something like that, as well as further up here. You could get something like this is September 82, where the crack happens within the caldera along that trend, can fill part of the depressions close by the caldera, but also has the potential to leak out some of these little gullies to the south and make little flows. So this leaked out of one of these caldera faults, but it hit another one down here and didn't make it out of that. That's not a possibility. We've discussed December 74 flow. That's this big red one right here. We're near this site of all of our earthquakes, the connection zone here. If it were to break out at the top and propagate fissures going down, I'm drawing them off the red since you won't see red on red. But this is the general orientation of them over here. That flow being very fluid and put lava a long way, all the way down here, all within 6 hours of breaking out of the ground. Yeah, we'll come back to this briefly in a bit as well. So that's a possibility. Or one last thing I'll throw out there, the earthquakes are plotted on here. Over here is a Pu'uko region right through here. Let me zoom in on this, even though it's too much, right? But what I want to show you is that there are big cracks in this area. All this is structure, big cracks all through here that are showing up on these satellite images all through here. To the point where, look at this flow. And this flow has actually got a finger of lava that filled this crack and helps highlight this topography even more right there. Okay, so this is an area of lots of cracks. There is the Pu'uko earthquake cluster. Let's follow this crack system down to here. There it is right there. Right, this is what is known as the Great Crack. And if you do that, you come to the eruption site of 1823 right through there. All right, so one interesting possibility here is if the magma is coming through these cracks all the way to here to Pu'uko, and we're seeing them get shallower and shallower here, and they're not quite to the surface, but do they need to get to the surface? Or do they need to somehow intersect this crack that also goes down quite a ways? If it does that, then it can have a pathway to then drain out right through there. So this pinch point is one that's always been interesting. There's no sign of this happening at the present right now. We're not seeing any increase in activity. We're just seeing occasionally a few earthquakes, a little bit shallower here. The ones I was pointing out to you guys was maybe half a dozen earthquakes, not that many. But it is a trend that if you were to see that intensify, that could lead to that being a more real possibility. So that on a map is a range of what seems possible, right? In the shorter and slightly longer term. And eventually, once we see this area, this block of land moving back to the south, then you might expect to see eruptions like Mauna Ulu, which is this guy over here, or Pu'u'o, which is this whole area over here, right? And all the way further down the rift, all the way to here, and that's where you get to 2018. Right? Well, quite a bit of a gap going on there, and you can see how this is much less frequent, right? There is a case in 1977 of Pu'ikiai over here putting a flow down as well. Similar to this Pu'u'o era, right through there. So we'll see. It's been 5 years since the 2018 collapse. We're seeing a lot of changes. We've discussed in the past how this whole south flank of the volcano, right, that whole thing like that, is having to get pushed to the side, but it's too long and too, what's the word? Oblong, maybe, to do it all at once, right? So we had this whole section over here go, and now we're seeing this section go, and now we're seeing this section go, right? So it seems like it might be just unhinging or doing a little bit of a shimmy, as we've described for a while. where this section moves, and then this section can have its turn, and this section can go again, and this section can go again, and eventually it works its way back. So in that context, not surprising to see Southwest Rift adjusting here, although it is fascinating, of course, since just as before, this is the best monitored area of the volcano. So we have the most data, and we can see the most going on here of any point in the past. So that can wrap up Kilauea for us today. I wanted to quickly summarize Mauna Loa once again. Here's a summit view of Mauna Loa earlier today. And here's some monitoring data from Mauna Loa. The tilt for the last week is basically flat. You see the daily variations. That stuff doesn't matter. You see a spike, it's an earthquake even detected. Also doesn't matter here for the overall ground tilt story. Our depth versus time for the last week is very blank. A couple of very deep earthquakes, but overall very little of anything, to be honest. For the past month, we do see the tilt showing that little deflationary step, which we previously pointed out corresponded with earthquakes on Mauna Loa's flank that followed earthquakes deep beneath Mauna Loa. So it could be that Mauna Loa is going through its typical filling and spreading cycle as it continues to recover from its 2022 eruption. So depth versus time, there is a deep earthquakes that have resumed here in December, and not a whole lot here in the last couple of weeks. Earthquake rates for the last month are pretty ridiculously low. Earthquakes per day, the maximum is 5. So that's really comical when you go back to the end of 2022 when we're having hundreds and thousands reported on the maps at some points in time. So for comparison, earthquakes per week, here's our most exciting part of 2023 for Mauna Loa, those deep earthquakes, which were noteworthy right there. But ever since then, it's been back to even lower background levels. And for the last 5 years, that little peak shows up just like this. So that's why I say it's comical. Here's a buildup of earthquakes to Mauna Loa's 2022 eruption, where we had over 1,200 earthquakes in 1 month back towards the end of 2022. No, this should say Mauna Loa. Mauna Loa. Right. So there's a map of earthquakes, Mauna Loa summit for the last month, and here it is for the last week, pretty blank once again, and that's really most of it for Mauna Loa. We did note that there was that little movement on the flank and the summit. All those little wiggles are all usually temporary, so the trends are still overall, it's filling and spreading as it recovers from its 2022 eruption. We do have an update from USGS, the monthly update for Mauna Loa, as well as other volcanoes. So we are still at the lowest level, alert level of normal, aviation color code green. They note the seismicity. Let's see here. Starting July 2023, there had been an elevated rate of earthquakes deeper than 8 miles beneath the caldera. Then this area saw a deep earthquake swarm in late October and early November. Since then, has returned to background levels. So that is the update on Mauna Loa. The USGS monitors more than Mauna Loa, of course. So just to step through the bases here, Hualalai is normal, nothing unusual. Haleakala on Maui is normal, nothing unusual. Mauna Kea, nothing unusual. Kame'ua Kanaloa, formerly known as Loihi, nothing unusual there either. That's it for the Hawaiian volcanoes. But given that this is Volcano Awareness Month, and there will be a talk on this coming up towards the end of the month, I'll throw in as well their monthly update for American Samoa. And nothing happening at Ofu Olosega, and nothing happening at Ta'u Island as well. Right, so these reports are coming out every month with little details like in December 2023, staff from USGS, HVO, and NOAA, Pago Pago replaced seismic station TAU, which had been damaged in May 2023 during a lightning storm. The station is now back online recording data normally. So if you were one of the people who were watching the Ta'u station, it's back online. And that is the Mauna Loa and other volcanoes update here. We do have a couple of volcano watches to catch up on for you guys. The one that was put out last week is about the New Year's Eve 74 eruption, December 74 eruption, which we've previously described here, so we don't need to go through into too much detail. That was that third new eruption of 74, but as we have previously noted, 74 began the year with Mauna Ulu already erupting, so it was really the fourth output of lava from a different vent in that year. So just to summarize the final buildup of that eruption, seismicity increase in the summit upper east rift regions for the month leading up to December eruption. By the evening, December 30th, the earthquakes were coming at a rate of 2 to 4 per minute. And just after midnight on December 31st, the alarm sounded, tilt meters deflated, and tremor began, indicating magma on a move out of the summit region. They saw fountains about 2 hours later, 2.5 hours later, almost 3 hours later, in the Kau Desert. The fountains reached 130 feet high, with lava bombs up to 330 feet high occasionally. 10 fissures opened over the first hour of the eruption, forming a near continuous fountain of lava that stretched over 2.5 miles. They declined by morning, and the eruption was over by 9 a.m. Only 6 hours long, but despite it being so short, the flow managed to go 7.5 miles away from the cracks, which meant the flow was unusually thin and fluid and bubbly. So it's typically less than 3 feet thick across that whole map area I showed you of 74. So that's a 74 eruption. In the end, we did not have our fourth lava vent of 2023 like we could have. 74 perhaps is still that special year, and understandably why they would recap that on New Year's Eve week in 2023. So that's the first one. There is another volcano watch from today, which is this: separating signals, what matters to seismologists. So there are many different seismic signals from human sources, from natural sources, and the idea is to know what's what, so you can focus on a volcano and what it's actually doing. So this is a new article, but covering old ground, and it's got an interesting graphic here showing the actual seismic trace. So you can see the wiggles here, and different kinds of wiggles might look similar, but they're actually pointing them out that if you look at these in spectrograms, you can then see quite a bit of a different signature, where earthquakes are very clearly different from helicopter noise, for example. So that is the topic of this week's Volcano Watch. There are some other things that we've discussed in the past as well. Instead of human activity, they're using this word anthropogenic. So that is the technical term there, caused by humans. And how there's more noise during daylight hours, just from foot traffic and cars and helicopters. Although, if you saw the new Hawaiian Volcanoes National Park flight plan, should be a lot less of those this coming year here. Yes, Dane.
Yeah, I was just saying, look how fancy they are using them terms, type of thing. I don't know. I just don't. I like it when we're trying to communicate with people, and these are supposed to be for people that don't have an undergraduate degree in the thing. Common terms, guys. Human noise pollution, whatever you want to call it, whatever you want to do with it. But yeah, I don't know. That's just me.
Yeah.
But I use weird terms personally.
This is a different kind of education, right? Because we're trying to educate as well, but we're trying to educate with a purpose of disaster preparedness, right? And they might be trying to educate in a more academic sense, where, well, here's an interesting term and here's another interesting term, and they do define it as human noise in here, but still doesn't really matter to most people who are trying to be more prepared. And so that's where we're slightly different.
Yeah,
with how we do
exactly.
it. Yeah. So that's Volcano Watch from this week. We do have a couple of community items to review. If you look at the National Park website here, alerts and conditions are a lot less. Now we're down to just one Mauna Loa trail close above Red Hill Cabin. And of course, the summit's still accessible by Pineapple Trail. Right? So that's a lot less than before. And the key difference that's relevant for us here is that the Mauna Iki Trail has reopened in the national park. This is as of December 28th. And if you're curious where this is, let me just pull out the map. And let's zoom it in to, let's see, that's the summit. There we go, zoom it into Mauna Iki area. So there is the summit of the volcano. Here is Highway 11. Here is the Kau Desert Trail. It goes off like this. Hilanapali Road. Mauna Iki Trail connects Hilanapali Road to the Kau Desert Trail right here. So it's reopened. That means all the desert trails are now reopened, as well as the Hilanapali Road. All right, so we could probably expect that will close again once activity comes back up. So if you're curious what it looks like out there, now might be the time to go explore. Given what we've seen, the park being more responsive in the last few months of 2022 here to seismicity and closing the roads once even the entire Chinook Critters Road was closed. And seismicity began in Upper East Rift Zone. So that's the park side of things. The National Park has plenty of talks, but they are largely part of Volcano Awareness Month from the USGS. So we'll recap that schedule as our last item here for you guys today. This week is off for Volcano Awareness Month. Officially begins on Sunday with a hike at Kahuku, 9:30 a.m., Birth of Kahuku. On Tuesday will be the first After Dark in the park, first talk. Kilauea's Crater Filling Summit Eruptions. So we will stream that to you guys live from the National Park on Tuesday. That'll be our next broadcast. We'll generally focus on these red events, the ones that are actually talks, to try to stream live to you guys. And where we can, we'll take other content and release it as we're able to. So we'll try to get some hikes, but no guarantee there. Those are a lot harder to record. Still, next Tuesday, we'll have that update from the National Park, and then we'll be back on for our regular Thursday update. The following week, you can see, is going to be full with talks on Tuesday in the park, Wednesday in Hilo at the National Park, or at the University of Hawaii Hilo, Thursday in Pahala. So Thursday, 6 p.m., we will likely not have an update this day because of this, right? Unless something unusual is happening at the volcano. And then on that Friday, a fourth talk for the week down in Pahoa, which we will also try to share with you guys. The following week there, After Dark on Tuesday, there's a talk from on earthquakes from the library in Kona on the 25th. We'll see about this day. I may not be able to do an update this day if I'm over in Kona at that point in time. So either we'll release a short video if needed, or we'll just coast through it if nothing is changing in the volcano here. Right, you can see this goes to the last week of January and strong, with 2 talks on the 30th and 31st in a national park for Mauna Loa and at UH for American Samoa. Right. Of the After Darks in the park, it's worth mentioning Southwest Rift and the Great Crack. This is relevant to what we just discussed today, right? This whole potentially eruptive area. And this one, Eruptions Near Kilauea Summit, is actually the generic title for the Kauai Fault Zone talk. This is the Kauai Fault Zone talk by Steve Lundblad from UH Hilo. So this one might be perhaps the highlight to me, because that is what's happening the most right now. And it's always interesting to hear the insights as activity is ongoing live outside of our doors. So that is our calendar for the month. And with that said, Dane, I'll let you say some thank yous.
All right. Yeah. Thank you, everybody, for tuning in today. We'd first like to start off by thanking the viewers like you that tuned in. That really does help drive the algorithm and, keep this thing, helped us get to where we are and gets us, more and more people that are maybe prepared a little bit more than they would have been otherwise. We do rely on the likes, the subscriptions, the shares, and all that stuff. It really does help with the algorithm. I know people are tired of hearing about YouTubers talk about that, but it's true. And without it, it really, you just get stuck in a void, and we can't be screaming into the void. So we really appreciate you guys tuning in, helping us with that front. We also do take donations. We had a couple come through. Want to acknowledge those real quick. We had Scotch Ed come through with a $20 super chat, and then Shaka Brands come through with a $10 super chat saying fascinating and valuable information. Thank you for making it easy to understand. I don't know what happened to Scotch. I'm gonna have to go look for that message because that didn't get saved for some reason, even though it should have. Anyways,
we know Ed,
Mike,
he's here every week.
Long time
Mahalo, Ed.
Says, here we go. Glad you guys got to take a break. Bigger blow. Yep. Much appreciated. Little reprieve from busy schedule and going into another busy schedule. And then also the comment there. So appreciate that support. We do take donations also on hvery.org/donate, and hvery is a 501c3 accredited nonprofit, which means you get your donations are tax deductible come tax time in a couple months or a few months. So yeah, we appreciate everybody that supports in that way. And yeah, we're just trying to, get this a little bit more going, and we appreciate everybody on the back end that's helping us. We have Rachel and Carrie, our ASL interpreters today. We appreciate them greatly. We also have Lou from Two Pineapples on the back end helping us with production and ready to jump in case Phil disconnects at any given time to the Hawaiian internet gods. All right. So yeah, I think that gets us through that. We do have some questions. It's been away for a little while, so maybe we should do some. There's nothing really, outside the ordinary, but we, go through some questions. What do you think?
Yeah, sure. Let's do some discussion.
All right. Shaka asks, does the transfer of magma to the rift zone mean the rift zone eruption is more likely? Or is that more just a signal that you'd come to expect? Or what are your thoughts?
Yeah. I mean, I think fundamentally, yes. You have to say yes, especially following 2018, when we saw the connections to the rift zones were disrupted, right? As we discussed, the East Rift with that little caveat where it was filling first and then got disrupted after the fact with a delay there. But yeah, absolutely. We haven't seen a Southwest Rift active in a while, certainly to this level, to this length, right? So It does seem like it makes it more likely. But I do like to remind people that the volcano grows just as much from filling underground as it does from eruptions. In fact, it might grow by several factors of volume larger underground than it actually erupts into the surface. Like most of the material might be gathering underground.
That's my impression of it. We just see it's like the tip of an iceberg almost to me. Not like maybe that dramatic, but more that way than a 50-50 in my mind. But maybe
I've heard up to 90%, right? So I mean, it probably varies place to place, varies in exactly what's happened recently, right? But you could have a situation after a big collapse where you have a 90% to 10% ratio of it filling underground because you have the space to do it.
Right.
So that's the thing.
Right. And a compromised transport, the conduit's been compromised, everything's compromised above it. And what's easier? Is it easier to just go underground or try and go vertical? So sounds like you got a visitor. Want to do one more question?
Yeah, I think that was something rattling against the wall at us. Yeah. But yeah. So something. Yeah, some vermin perhaps. So that's really the thing. It could be filling quite a lot of space underground. And let's do more questions.
All right. Nicholas asks, why Mauna Loa's lava lake inactive versus Kilauea? I think that's like, why does Kilauea have lava lakes, but we don't see those on Mauna Loa, or we haven't in our lifetimes at least. Unless you want to call like the floor of the caldera getting covered in the early stages of an eruption a lava lake, right? It's kind of very too short-lived, right?
Yeah, not exactly. Yeah, I mean it's interesting because Mauna Loa's glory days, which did include at one point a 2-year lava lake, if I recall correctly,
Mm.
were all prior to this modern advent of instrumentation, right? So we've talked about this in the years of Mauna Loa buildup, right? How there were lava lakes up there, and people weren't up there continuously. People had to walk up and look in and look, oh, is it still there? Okay, it's still there.
Right.
And sometimes you could tell from far away if the clouds were just right, but there are times people would walk up from far away and not see any glow and get up there and look in, and there was a lava lake still. So it was really hard to tell from far away. Places like Hilo, everyone lived, and we don't know much about that era of it. So what we can say is it has happened in the past. During that era in the past, it seemed like Mauna Loa was more active than Kilauea. We have in the past referred to this potential connection of Mauna Loa and Kilauea, where it seems like Mauna Loa was more active and Kilauea was less active. Kilauea became more active, Mauna Loa became less active. They kind of are switching off to some degree. And right now, it appears to, at least up until recently, maybe it still is, we'll have to wait and see what Mauna Loa does, but it appears to be Kilauea's turn. And Kilauea is the one having the lava lakes at the summit because it's got a more steady, we'll call it, magma supply. A larger and more steady magma supply feeding it at present. But that can switch. And it seems like in the past it was at Mauna Loa, right? I don't remember the exact years, in the 1800s, that the 2-year lava lake was.
Right. And with the 2018 eruption and all the changes at the caldera, the collapses and all that, that was one of the questions we were asking is, so is this big enough to trigger the switch between Kilauea as the primary and go back to Mauna Loa? And we were talking with, I remember Don Swanson about that, and Don was like, nope, it'll still be Kilauea. Sure enough, it's still Kilauea. We did get Mauna Loa to pop its head out, but otherwise, one volcano is dominating the show still.
Yeah, it was a little bit of both answers, right? It was, Kilauea's input is too strong and established to stop and switch to Mauna Loa. That seems to have been true. And at the same time, there has been more response from Mauna Loa as well. So we'll see where we're actually going. This is all geologic timescale stuff, so we witness it like in super slow motion, and we have to check back in every year. Like, okay, what do we know now? And we just have to wait for it to develop still.
Right. The time is a big factor. Time away from the events that you're talking about, just the ability to review with the. I mean, this is true in that throughout history. Being able to review something without the passions of the day being influencing, with the whatever's being looked at that time. But yeah, it's interesting. We are now at an hour and a half. Phil, we did get through our questions here. Believe that, we'll just be coming back next week, Thursday, correct? And then with additional coverage in between, at least for the next week, that's the plan. Is you have another update coming with additional coverage coming in between with the events that we're able to post. Yeah, from the Volcano Awareness Month.
Yeah,
awesome.
So it'll be Tuesday, Thursday, and then we'll update you guys on Thursday about the following crazy week at that point.
Right, when we figure it out a little bit more on how it's exact. It's always, prone to whatever the volcano does, right? We get an eruption that changes things. We're going to have to go live. We'll give you an update if, the situation warrants it, right? And we said this every week, and nothing changes going forward. If the activity says that we need to go live, then we'll go live.
Absolutely. Mahalo to our ASL interpreters once again, Kiri and Rachel. Sorry, Rachel, got your name wrong. And Happy New Year, everybody. And until next time, until next week, from Hawaii Tracker, from Hawaiian Volcano Education and Resilience Institute, he is Dane DuPont. I am Philip Ong. Aloha, everybody.